Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. In this video, I've been asked to prove this trigonometric identity, which says that 1 plus sin2x divided by 1 minus sin2x is equal to sec2x plus tan2x all squared. And I've been asked specifically not to use the t formula. So in other words, not to let t equals tan theta on 2 and then using substitution get to this result. So if you do find my explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions other students are struggling with, be sure to subscribe to my channel so that you can stay in the loop. Alright, so we're being asked to prove this result 1 plus sine, new pen. Alright, lucky I got a big collection. So let's start again. We're asking to prove 1 plus sine 2x divided by 1 minus sine 2x, that is equal to, and it's all squared, we want the sec of 2x plus the tan of 2x all squared. So that's what we need to show, and often when faced with these kinds of proofs of identities, you can either start from the left-hand side and get to the right-hand side, or you can start from the right-hand side and get to the left-hand side. Either way will be a valid approach. For me, I'm going to start from the right-hand side and prove that that gets you something that's equivalent to the left-hand side, because I think it's just a little bit easier. So if we say our right-hand side is equal to, and what I'll do first is I'm going to rewrite both of these items in terms of sine and cos. So sec2x we can write as 1 on cos 2x, because that's the definition of sec, it's 1 on cos. And tan 2x I can write as sine 2x on cos 2x, since that's the definition of tan, sine on cos, and that's all squared. So that's our right hand side. Now the good news is we've got a common denominator here, so I can now write that as 1 plus sine 2x on cos 2x squared, and what I'll do is I'll square the top and bottom. So that's going to be 1 plus sine 2x squared over cos squared 2x. And what I can do there is write that as 1 plus sine 2x all squared divided by 1 minus sine squared x, 2x. And the reason I can do that is because we know the common result, sine squared x plus cos squared x equals 1. So here we've just got 2x instead of x, but the result still holds. Now what I can do is notice that the bottom here, this denominator, is the difference of two squares. So I can write that as 1 minus 1 plus. And also what I'll do is this numerator, I'm just going to write out the 1 plus sine 2x twice since we're squaring it. So 1 plus sine 2x times 1 plus sine 2x, and you'll see in a moment why I find that helpful. And so this difference of two squares I can write as 1 minus sine 2x times 1 plus sine 2x. Now this 1 plus sine 2x in the numerator and denominator we can cancel, and so that gives us 1 plus sine 2x over 1 minus sine 2x, and that is the left hand side. Panic boom! So there we go, that's the proof. We've started from the right hand side, and just using the rules that we're familiar with, we get back to the left hand side. In theory, if you wanted to, you could actually start from the left hand side and almost do these steps in reverse. So you'd probably start by multiplying top and bottom by the conjugate of the denominator. Then you kind of get to this result, then you get to this result, and then hopefully you'd notice what you were dealing with and eventually get back to this right hand side. But either way, you get to the right place. So hopefully you found that helpful. Hopefully you've been able to follow along with that, and having now seen this approach, hopefully you could, replicate it yourself if you had to. So there you have it, and tick boom.